They are fractions that have polynomials, many terms. Okay, so if there's an x in a fraction, okay, it's probably a rational expression. Okay, so we're working with fractions, but fancy fractions. And so to simplify, when we are asked to simplify a rational expression, that means we're going to factor it and cancel out similar or like terms. Okay, so that kind of gives me a sense of what a rational expression is. Okay, who can tell me what? Oh, one second. What is 0 divided by 2 equal to? Just say it out loud. Okay, what is 2 divided by 0 equal to? Undefined. Good. What does that mean? What does undefined mean? Do we know? Or you're like, oh, my calculator says it's an error. Do you know what it means? It means that the number is so ginormous that we don't have a word to explain it. Okay? So the smaller the number in the denominator, the bigger the value. Watch this. 100 over 100. What's that equal to? 1. 100 over 10. What is that equal to? 10. 100 over 1 equals 1. What is 100 over 0.1 equal to? Oh, shoot, this is 100. It would be 1,000. So, do you notice that as these numbers are getting smaller, as the denominator gets smaller, the value of the fraction gets bigger? And so when we get to like a denominator of like 0.000000001, you're getting a ginormous number, to the point that when your denominator is 0, that number is so big that we just don't have a word for it. We don't have numbers for it. So we say this value is undefined. Okay? And we can't deal with that. What? Undefined? No. So we just don't go there. Okay? And so we need to make sure, as we're working with rational expressions, that we set up our rational expressions in a way that the denominator does not end up equaling 0. Okay? Okay. So the way that we do that is we state a restriction. I will show you an example. Restrictions are what we do to ensure that the denominator is not 0. All right, so let's look at an example. Simplifying rational expressions with monomials. So I have a monomial and a monomial. Okay, now when I have a fraction that is 9 over 12, I know I can divide the top and bottom by 3. And so my fraction, when I simplify it, meaning I have smaller numbers, I get 3/4. Now, 9 over 12 equals 3/4, right? It's still 75%. It's still the same value. So when we're simplifying fractions, we're not changing the value. And so we're going to do that to this fraction. We're going to simplify it, but ensure that it still has the same value. We've got some x's and y's here, so things are a bit different. Let's just review. If I have y to the 5 over y to the power of 7, what that means, y. It's like that kid, like when you were toddlers and you were like, but why, Mom? But why? But why? This is your equation. 6, 7. Okay, so what this means is y is multiplied by itself 5 times and in the denominator 2 times. And remember in grade 9, we said, okay, we can cancel out the y's, 1 y from the numerator, 1 from the denominator. And look, I'm left with 2 in the denominator. So that gives me that the simplified version is y squared. Now that's a lot of work. So instead of doing that, we've got two options. I could say y, 5 minus 7. What does that give me? -2. If I have a negative, that's telling me this is the reciprocal. And a reciprocal of the reciprocal means that the y goes into the denominator. Yeah? Now there's another way. What I prefer, so what we did is we said top exponent minus bottom exponent. I prefer looking at it critically and saying which exponent is greater, which exponent is bigger, numerator or denominator? Denominator. That means the y will end up in the denominator. How many more? What's the difference between these two? 2. And so I would actually skip right to going 1 over y squared. Okay, that's a. Or you could say, okay, I know it's going to be in the denominator, so I will go 7 minus 5. Do you see this? I've given you a few options how to deal with exponents. Okay? All right. So let's go ahead and simplify this. This rational expression. So let's start with the coefficient. A coefficient is a number in front of a variable. So I've got 4 and 16. What do they simplify to? 1 over 4. Okay, so I've got my fraction line. I start with 1 over 4, right? And so we just deal with each variable and each coefficient on its own. Okay, then I've got the x's. So where is the exponent higher, in the numerator or denominator? Okay, so that means my x will end up in the numerator. What's the difference? I've got x2 and x, which is really x1. Okay, so I end up with an x in the numerator. Okay. If you want, you can still write 2 minus 1 to sort of show the process. Then I've got the y's. Okay, where is the y exponent bigger, numerator or denominator? Okay, so it's going to end up in the denominator. And I will go 5 minus 3. Okay. Do I need to write the 1? No. So in the numerator, I have an x. In the denominator, 4y squared. Let that digest a bit and ask questions. You folks have wonderful questions. Don't turn the page. Great. That's what we're going to. So what value can the denominator not have? 0. Okay. Now, let's remember the rules of multiplication. If I have a times b times 0, what does that equal to? If I have -3 times x times 0, what does that equal to? So if any of the multiples is a 0, the entire the entire expression becomes 0. So what that tells us, 16 cannot be 0, but we know that. What can x not be? Right? Because if x is 0, then I go 16 times 0. Oh, okay. So x cannot be 0. Okay, let's look at the y. How about y? What would happen if y was 0? Well, 16 times x times 0. Oh, so all of this would be 0. So y also cannot be 0. So these are restrictions. I'm saying this is a simplified version so long as x and y are not equal to 0. Okay, I do see a telephone out. Put it in your bag. Okay, so that's what a restriction is. Let's try more and get a sense. Now, you could also, if you want to be really efficient, you could say this. You could make a list. X and y cannot equal to 0. Right? You could write it that way. X comma y can't be equal to 0. Okay, so it's sort of like a list format. Good? All right, let's try another one. Okay. Yeah. All right, example 2. Now we've got a binomial. So anyone remember what we have to do? Or not remember, what are your thoughts? Yeah, so here's a question. If I have 3 over 6 plus 2, can I do this and say, okay, that equals to 1 over 2 plus 2? Well, let's see. That would give me 1 over 4. However, if I didn't cancel, I would get 3 over 8, right? 3 over 6 plus 2. Is that the same value? Okay, so this is a common mistake. So the only time that I can cancel is if everything is in the form of multiples. Yes?
Can you go through that step where you just did not the bottom one is 3 over 8?
I said 3 and then 6 plus 2 gives me 8.
Do you not do that? Or do
You do that. This is good. So we're like, so this is common. The common mistake that I'm suggesting is crossing things out when I don't have it in the following format. This, in this case, is everything is factored. Everything is in the form of multiples. Like look at the denominator, 6 times 2. Good. If everything is being multiplied or divided, because this fraction tells me it's divided, then I can cancel things. Okay, so here I can cancel the 3 and the 6, right? And that becomes a 1 and a 2, and I get 1 over 4. So only cancel when all terms are being multiplied or divided. As such, can I cancel these x's? No, not yet is the answer. All right, Luke had a great idea. Why don't we common factor? Okay, there's nothing to factor in the numerator. So let's leave the numerator as 12x. What is the common factor of the denominator? You got it. I heard it loud and clear, 3x. Okay, 3x squared divided by 3x is just x. Negative 9x divided by 3x is minus 9. Okay. Oh, yeah, it's not. Thank you, thank you. Yeah, great. Okay, now, can we cancel things out?
Yes.
Because everything is being multiplied. Well, but inside the bracket it's not being multiplied. That's okay. It's contained in a bracket. So this is a multiple of its own. It's 3x times x minus 3. So now I can cancel out. So I'm going to cancel out the 3x and the 12x. And what remains in the numerator? 4. Okay, so the 12 and the 3 are simplified to a 4. And the x get canceled. We good? Yeah. Like here? You could, but I'm trying to show you something simple so that when it gets more complicated, you know the first common factor. Okay? All right, so we are left with 4 over x minus 3. I can't common factor. I'm done. Okay, let's look at restrictions. So here, I know that the denominator can't be 0. So basically, x minus 3 cannot be equal to 0, right? But that's not a restriction. I want to know exactly what x cannot be. So let's solve for this. If you bring the negative 3 to the other side, we find out that x cannot be equal to 3. Okay? That's our restriction. And so if you want to see how to really nicely format it, that might be some work on the side. The way that we format it is we give the simplified and then we say comma so that x, so long as x cannot be equal to 3. Yeah, Luke?
I don't think we did enough first step if it's 12x and then the 3x outside the brackets.
This step?
Yeah.
So I said, okay, I'm going to simplify a fraction. 12 and 3 simplify to 4 over 1. And the x are identical with an identical exponent. So they just get canceled. Okay? We'll get, if we practice again, we'll do that. Okay. Sometimes you may have to factor out a negative. Folks, this is going to be on the test. Okay? Watch it. So sometimes you have to factor out a negative to generate a common factor. So if I look here, I'm like, okay. And I'm just going to pretend that I'm like, I have no idea what to do yet. Okay? So I've got 1 minus x. Actually, I won't do the numerator yet. Let's factor out the denominator. It's a factor of 2. And when I factor it out, x minus 1. Isn't that so similar to the numerator, except flipped? So in the numerator, the x is negative and the 1 is positive, and that's flipped here. So watch this. I'm actually going to factor out a negative 1 from the numerator, meaning I'm going to divide each term by negative 1. So when I go positive 1 divided by negative 1, I get minus 1. Negative x divided by negative 1, I get plus x. This is starting to look better. You can eventually skip this step. I just want to show you what's happening. So what do I get? So I have negative 1. And then if I rearrange the binomial, it's x minus 1 over 2x minus 1. Ooh, they are twins. Can I cancel out the x minus 1s? Look at numerator, look at denominator. Are they all being multiplied? Yes. And so as you can see, this x minus 1 is an entire term. I'm canceling out the entire multiple of x minus 1. Now, eventually you might be able to do this in one step, right? Or 2 steps, but I'm just showing you all the steps. And I'm left with negative 1 half. Restrictions? This is where people get stuck. But in the end, there isn't an x in the fraction. So I don't need restrictions. Not true. To set restrictions, we look at the entire solution. And we set restrictions for the entire solution. So at some point, we had a multiple of x minus 1. We need to make sure that x minus 1 does not become 0. So what value can x not have? Positive 1, right? So here's my work on the side. So x cannot be positive 1. But then to state the restrictions in a well-formatted way, I write a comma after the simplified version, and I say such that x cannot be equal to 1. So what we're saying is this rational expression can be simplified to a value of negative 1/2 so long as x is not equal to 1. Because if it is, I don't know what to call it. It's undefined. Okay. Ooh, look at this fun one. We're just getting better and better. All right. Yes. Please.
Like instead of factoring out a negative, if you just do negative 2 to the denominator.
Like, oh, I love that. Great idea. What Victoria said, and that's actually more efficient, is she would factor out, let's show that because I just love it. So Victoria's saying, okay, instead, let's keep that 1 minus x. Let's not change it. But we're going to factor out a negative 2 from the denominator. And that will give me negative x plus 1. Do you see that? And like, you don't have to write it this way. You can swap the order right away, right? Like I know, like I would know what you're doing if you skipped this step and went straight to 1 minus x over negative 2, 1 minus x. Right? So if you skipped, that is A-okay. Now, as much as I'm encouraging you to skip, I only want you to skip if you're comfortable with it. Okay? And then we're like, oh, we can cancel this and that. Love it. Yeah. Okay. So we got 2 ways. Both ways are good. Both ways are right. All right. Please. A 1. Because these are identical, whenever you're saying this divided by this is just equal to 1. Ooh, look at this fun stuff. Wow. I'm really making Friday great today. All right. I'm going to give you a minute to talk to your person. Timon, maybe you turn around and listen to the conversation with Sophie and Lila. What is your approach to this question? Don't do it, or if you want, do it on the side. What is your approach? What do you notice? Are there any shortcuts? How are you going to factor? Okay. When you're looking at this, do you see anything? Can we factor? So is there a common factor? Nope. Because this doesn't have 3. So there's no common factor actually. But it's a trinomial. Do you see this? A trinomial? So even though there's like it's ugly with x and y, you're gonna just factor as a trinomial. Yes, so you're gonna do this separate. Okay? Yes. All right. Thoughts. Astrid, what were you thinking? Listen up, folks. We've got wisdom coming.
Well, we were thinking about common factoring, but then not all terms have x. We couldn't do that one.
Beautiful. But they thought about it. Love it. Okay. Lily, did you have more thoughts?
Yeah, so what we did is we just used the you start off by using the a is equal to 1 scenario. So
yes. Simple trinomial factoring. Beautiful. That is what we're doing. Now, did anyone notice a shortcut? Liam, what is it?
The square binomial, or it's the...
Yeah, the SAB opposite, the SAB factoring. It's called PST, perfect square trinomial. Which one, numerator or denominator? Yeah. Anyone else notice PST? Okay, no sweat if you didn't. Practice it. Marley, you did? Great. Practice it. Get comfortable with it, right? Find it. So what do we mean? Okay. So I'm glad people looked for common. Who looked for common factor first? Yay, pat on the back. Good job. All right. Okay. But there are no common factors. So now we're going to factor numerator and denominator. And so I'm going to factor this as a PST. And that stands for perfect square trinomial. And if you're not sure what this is, Google it. Like, learn it, right? Because it's just going to help you. So what that means is Liam and Marley recognized the first term is a perfect square. What is the square root of the first term? What's the square root of x squared?
Yes.
Yeah. The second term is a perfect square. What is the square root of the second term? Sorry, last one, 3y. And then the way that I do it is I check the SAB rule. If I multiply this term by this term and double it, does it give me the middle term? Let's see. X times 3y equals 3xy, and then doubled gives me 6xy. Yes, it works. Good. Now, here's the question. Do I place a negative or a positive in the middle here? If I have a negative, it must be negative. So we place a negative, and this binomial is squared. So we end up with a squared binomial. Would you get the same result if you just factored as if you're doing a simple trinomial? Absolutely. Okay, so if you didn't catch it, no sweat. Now, this one is not a perfect square trinomial because 18 does not have a perfect square. So in this situation, we put a plus on top of the middle term, a times on top of the last term. I'm looking for two magic numbers that multiply to give me 18. And add up to give me negative 9. 18. 18 is going to be 9 times 2, 18 times 1. What's the big one? 6 times 3. That's right. Okay, now tell me about negatives. So it is 6 and 3. Are both negatives, both positive, one negative, one positive? Both negatives. Has to be, because negative times negative gives you positive. All right, so my magic numbers are 3, and I'm going to leave a bit of space, 6. Now, the x part is, you know what to do with that, right? You're like, I know, I just put an x at the front. What do I do with the y? It looks so scary, Miss Y. It's not. It's part of my last name. It's cool. Don't worry. I can vouch for it. So if you have a y squared, you kind of do the same thing as you would do with the x squared. See, you got the x squared, so you just split it up as x and x. So you do that with the y squared. You split it up, but now it's at the back of the binomial, y and y. Okay? Do you see anything? Now we are being asked to simplify. Is there anything we can cancel out? Talk to your partner. What can we cancel out? Do you know, Polly? Do you know what we can cancel out? Meaning, is there anything here and here that is identical, the same? And it's not just the threes, it's this entire binomial. Okay. All right, come back. That is not math talk. All right. Folks, I want to pause you. I want to tell you about my superpower. I've got many. One of my superpowers is I can tell, even if I can't understand the words, I know if you're talking about math or not. There's something called math talk, and math teachers know the sound of it. And I noticed that there was some math talk and then there was some not math talk. That's why I'm bringing you back. So binomial squared means you write it twice. This is a step that can be skipped, okay? And so we're saying, okay, everything is being multiplied right now. This binomial times this binomial is timesing this binomial. So I cancel out one of each binomials that are identical. Now, if you want to skip that step, do you know what, if I were to cancel here, what would I be canceling? What would I be crossing out in the numerator? No, the 2, the squared part. So if I were working here, I would cancel out this numerator and just the squared. Okay, up to you. Skippable. Is that a word? I don't know. Sounds like a good one. All right, so I end up with x minus 3y, x minus 6y. Is it simpler? Yeah, it's simplified. Okay, restrictions are a bit ugly here. So basically, folks, come back here. I will give you time to talk math. I love that you want to. Okay, but there are many of you. Basically, each of these brackets cannot equal to 0. So what we're saying is x minus 3y cannot be equal to 0, right? Yeah.
Would this be would you be able to say that this is equal 1 over 2 because of 3 and 6 or no?
Great question, and you can't. Because these are not being multiplied. So you stop there. Okay, so watch this. I want to know what x cannot be. So I bring the negative 3y to the other side. Do you know what x cannot be? X cannot be equal to 3y. Because if I had 3y minus 3y, that gives me a 0. Okay, let's try the other one. Okay, so I've got x minus 6y cannot be equal to 0. So x, similarly so, cannot be equal to 6y. Feels weird. Just go with it. And then we make our beautiful list along with our solution. One sec. So I'm saying this is simplified so long as x cannot be equal to 3y or 6y. And then I think I know actually, I don't know if I know and then I look through every denominator. Yes, I accounted for each of these. Yes, I accounted for this and I accounted for this. Do you know what a common mistake is with restrictions? Is that students will, do you know it?
Isn't you trying to restrict y as well?
No, that would be okay actually, because it's a variable. Because this kind of goes both ways. Like, you could also have said y cannot be x over 3. That's cool. Students think they have to restrict the numerator, right? So maybe in the next one, I'll show you what I mean by that. Okay, last question of the day. Yes.
Do you not take up 3y, negative 3y is not a equation? Divide up negative 3y.
Okay. So second question, meaning I got to address it. Folks, listen up. Another common mistake. Tell me why canceling this and this would be a mistake. Say it loud. They're not being multiplied. This and this are not being multiplied. This and this are not being multiplied. Does that make sense? Thank you. Such a common mistake, okay? So thank you for bringing that up. All right, last one. Sometimes these expressions, these rational expressions have really complex factoring. So we might want to factor on the side, which is what we're going to do for this one. So we're going to take the numerator. I check for what? Common factoring. There's none. So I've got 2b squared minus b minus 15. Okay, I can't common factor. A equals 2. So I must do decomposition. Okay, so I do my times, and then I draw my plus on the middle term. What is the coefficient of the middle term? There's no number there. -1. Good. So I'm looking for a number that adds up to -1. I'm looking for two numbers that multiply to be, what do they have to multiply to be? -30, 2 times 15. All right, my options. 15, 2, 31. What is it? I heard it. 6 and 5. Yeah. 6 and 5 will give you 30. 6 and 5 will somehow give you 1. And so now I have to figure out which one has to be negative. My rule generally for the addition part is if my answer is negative, that means the bigger number has to be negative. If the sum is positive, the bigger number has to be positive. So that would mean that 6 has to be negative because I have to end up in the negative area. So, okay. And so we decompose. Two b squared minus 6b plus 5b. You want to do a different order? Please do it. Okay. Now we're factoring by grouping. Okay, so we factor this group. Their common factor is 2b. So I get b minus 3. And I'm really hoping that my next common factor will also give me b minus 3, and it does. And then a few people forgot that with decomposition, this last step, a few people forget this last step. So the last step is that we write b minus 3, and then we bring the two coefficients into the second fraction. Okay, so we stop there. We've basically factored the numerator. Now let's factor the denominator. What are you seeing? As soon as you look at the denominator, what do you see? Yeah, there's a common factor. And that is going to make this a lot simpler. 2. Watch this. B squared. Ooh, it's a simple trinomial. Oh, man. That's easy peasy now. Okay, I'm not going to say that because I know for some you might not feel that. That's fine. Okay, but if it's a simple trinomial like a equals 1, it's just find two magic numbers that add up to -2, multiply to -3. So I've got the 2 out front. B minus 3, b plus 1. And then I kind of steal a look at both of them, and I'm like, do they have a similar multiple? And they do. And I'm like, yeah, I'm probably on the right track. Awesome. All right. So let's work to simplify this. Okay. So the numerator has been simplified to b minus 3 times 2b plus 5. And the denominator has been simplified to 2 times b minus 3 times b plus 1. So all factors are multiplied. That's good. Tell me out loud, what can I cancel out? You got it. Hooray. Let's cancel out b minus 3, b minus 3. Okay, if we're not sure if we can keep going, let's just write what we've got left over. So I've got 2b plus 5 over 2b plus 1. Okay, check both for common factors, none. This is all I can do. Let's state restrictions. So try to do this part on your own. Okay, take a second. We got plenty of time. Today's a short day. Okay, so for b plus 1. So folks, like what you can do this part in your head. You don't have to write down how to find the restrictions. So if you look here, for this multiple, what cannot be equal to? B plus 1. So it's like the opposite of the plus 1, right? So I'm like, okay, so b cannot be equal to -1. Okay, look at, now, do I give a restriction for b minus 3? Yes. Because at some point, b minus 3 was in the denominator. So for this binomial, what is it that b cannot equal to? Okay, b minus 3. So if b was a 3, 3 minus 3 is 0. So -1, 3. How about this multiple, this binomial? Do I find a restriction for it? Why not, Annabelle? Good. It's in the numerator. No need. Can the numerator be equal to 0? Yeah. So I'm writing no need to restrict numerator. We good? All right, folks. So you can put your, so is there homework?
That the course
Yeah.
fair will be happening at
Put your stuff away and then put the desks
in the
back.
lower gym. 11:35 in the lower gym.
What?
Hope to see you there. Thank you.
Doesn't lunch start at 11:25?
Yeah.
Okay. So yeah, there is homework. Put your stuff away and put your desks back. Let me see.